Applications of context-free grammar in natural language processing. Grammar. So what is grammar? Grammar is defined as the set of rules for forming well-structured sentences. While describing the syntactic structure of well-formed programs, grammar plays an essential role. In simple words, grammar denotes syntactical rules that are used for conversation in natural languages. The theory of formal languages applies not only to NLP, but also in the fields of computer science, mainly in programming languages and data structures. For example, in the C programming language, the precise grammar rules state how functions are made with the help of lists and statements. Mathematical representation of grammar. Mathematically, a grammar G can be written as a four-tuple, which has four elements n, t, s, and p, where n or vn is the set of non-terminal symbols or variables. T or sigma is the set of terminal symbols, s is the starting symbol where s belongs to n, and p is the production rules for terminals as well as non-terminals. It has the form alpha defines beta, where alpha and beta are strings on Vn union sigma, and at least one symbol of alpha belongs to Vn. Context-free grammar, CFG. Context-free grammar, which is in short represented as CFG, is a notation used for describing the languages, and it is a superset of regular grammar, which you can see in the following diagram. CFG consists of a finite set of grammar rules having the following four components: set of non-terminals, set of terminals, set of productions, and start symbol. Terms related to CFG. Set of non-terminals. It is represented by capital V. The non-terminals are syntactic variables that denote the set of strings which helps define the language generated with the help of grammar. Set of terminals. It is also known as tokens and is represented by sigma. Strings are formed with the help of the basic symbols of terminals. Set of productions. It is represented by P. The set gives an idea about how the terminals and non-terminals can be combined. Every production consists of the following components: non-terminals, arrow, terminals, or a sequence of terminals. The left side of the production is called non-terminal, while the right side of the production is called terminals. Start symbol. The production begins from the start symbol. It is represented by the symbol S. Non-terminal symbols are always designated as start symbols. Parse tree. A parse tree or parsing tree or derivation tree or concrete syntax tree is an ordered rooted tree that represents the syntactic structure of a string according to some context-free grammar. The term parse tree itself is used primarily in computational linguistics. In theoretical syntax, the term syntax tree is more common. Concrete syntax trees reflect the syntax of the input language, making them distinct from the abstract syntax trees used in computer programming. Natural Language Processing, NLP. NLP stands for Natural Language Processing, a part of computer science, human language, and artificial intelligence. This technology is used by computers to understand, analyze, manipulate, and interpret human languages. Natural language processing is a subfield of linguistics, computer science, and artificial intelligence concerned with the interactions between computers and human language. In particular, how to program computers to process and analyze large amounts of natural language data. NLP algorithms are widely used everywhere in areas like Gmail, spam, AnySearch, games, and many more. Importance of NLP. Text data in a massive amount. NLP helps machines interact with humans in their language and perform related tasks like reading text, understanding speech, and interpreting it in a format. Nowadays, machines can analyze more data than a human more efficiently. All of us know that a lot of data is generated daily from various fields such as the medical and pharmaceutical industry and social media like Facebook, Instagram, etc. And this data is not well structured at all. That is, it is unstructured data. So it becomes a tedious job, and that is why we need NLP. Unstructured data to structured data. We know that supervised and unsupervised learning and deep learning are how extensively used to manipulate human language. That's why we need a proper understanding of the text. NLP is very important to get exact and useful insights from the text. Meaningful information is to be gathered. Components of NLP. NLP is divided into two components: natural language understanding, natural language generation. So, the first, natural language understanding. NLU helps the machine to understand and analyze human language by extracting the text from large data, such as keywords, emotions, relations, semantics, etc. Natural language generation is the process of extracting meaningful insights as phrases and sentences in the form of natural language. It consists of text planning and sentence planning. So here are the phases of NLP. If we have speech or text, first we go through with phonological analysis and OCR tokenization. And then we go to the first level of NLP, morphological analysis. In this level, we find out the primitive unit of meaning. In the next level of NLP, we do lexical analysis, which tries to interpret the meaning of individual words. Following that, we have syntactic analysis, where we uncover the grammatical structure of sentences. The fourth level is semantic analysis, where we check for the meaningfulness of our text data. The fifth level is disclosure integration, where we focus on properties of a text as a whole and making connection between sentences. The sixth and final NLP level is pragmatic analysis, where the meaning of a sentence is applied to various situations like real-world knowledge. Application of CFG in NLP. Syntactic categories of NLP are NP, which is noun phrase, VP, which is verb phrase, S, which is sentence, DET, which is determiner or article, N, which is noun, TV, which is transitive verb, which takes an object, IV, which is intransitive verb, PREP, which is preposition, PP, which is prepositional phrase, ADJ, which is adjective. From context-free grammar, we can say that S defines NPVP, which means a sentence is defined as a noun phrase followed by a verb phrase. So a sentence in the language defined by a CFG is a series of words that can be derived by systematically applying the rules, beginning with the rule that has S on its left-hand side. For example, let us parse the sentence, "The giraffe dreams," and we have the following derivation, where S is defined by NP-VP. Now NP is noun phrase and VP is verb phrase. Noun phrase can be split into determiner and noun, followed by VP. Now the determiner we use here is the, and the noun here is giraffe. Now the verb phrase is an intransitive verb, which is dreams. So that's how we get "the giraffe dreams." A convenient way to describe a parse is to show its parse tree, which is simply a graphical display of the parse. So as we can see, S is divided into two components, NP and VP. NP further divided into two components, determiner and noun. The determiner is the noun is giraffe, and the verb phrase, which is an intransitive verb, is dreams. Thus, we get the sentence, "The giraffe dreams." So what are the advantages of applying CFG in NLP? Well, CFG provides a formal framework for describing the syntax of a language. CFGs consist of a set of rules that define how words and phrases can be combined to form sentences, making them a useful tool for analyzing the structure of natural language. CFG is capable of generating an infinite number of sentences that are grammatically correct. This allows NLP systems to recognize and generate a wide variety of sentence structures, which is essential for applications such as text parsing, machine translation, and language modeling. CFG can be easily parsed using algorithms such as CYK algorithm. This makes it possible to analyze the grammatical structure of a sentence and extract information such as subject-verb-object relationships, which is useful for tasks such as sentiment analysis and named entity recognition. CFG can be used in combination with other techniques such as probabilistic models to improve the accuracy of NLP systems. For example, CFGs can be used to generate candidate parsers of a sentence, which can then be scored based on how well they fit in the context of the sentence. Thank you.